There is no outside to this question. Every other question you can ask has a surrounding context. Why did a species go extinct? There's an ecosystem around that. Why does water freeze? There's chemistry, thermodynamics, a physical world surrounding that. But this question, why is there something rather than nothing, has nothing surrounding it, no larger framework to appeal to, no prior conditions to invoke without immediately asking where those came from. This is the only question that consumes every answer you give it and asks again. I'm Paul Dirac. I want to think through this with you, carefully, without pretending it's solved, without pretending it's unsolvable, because the serious attempts to answer it, from physics and mathematics and philosophy, reveal something precise about the limits of explanation itself. And that precision is, I think, more interesting than a false answer. Let's start with a problem that almost everyone skips. Before you can ask why there's something rather than nothing, you need to ask what nothing actually is. And this turns out to be genuinely hard. Your first instinct is probably nothing is empty space. But empty space is something. It has geometry. It has dimensionality. In quantum field theory, it has energy, the zero-point energy of quantum fields, fluctuating even in the absence of any particles. Empty space is not nothing. It's a very specific physical state with very specific properties. All right, nothing is the absence of space then. No space, no time, no matter, no energy. But now you've hit a different problem. The absence of space and time is a description, a concept, a piece of language operating inside a logical framework. The logical framework is something. The concept is something. Every time you try to rigorously define absolute nothing, the definition itself requires a scaffolding, rules of logic, mathematical structure, a framework within which the concept can exist. And that scaffolding is not nothing. True nothing, no space, no time, no laws, no mathematical structure, no potential, no possibility, may not be a coherent concept at all. It may be that nothing in the absolute sense is not a state the universe could have been in, because being in a state is already something, which means the question, why is there something rather than nothing, might be asking why reality chose one option when the other option was never actually on the table. That's not a resolution, it's a sharpening. Keep it in mind. Now, what does physics say about the beginning, the Big Bang? 13.8 billion years ago, the observable universe was in an extraordinarily hot, dense state and has been expanding and cooling ever since. The evidence is overwhelming and the model is precise. Cosmic microwave background radiation, the abundance of light elements, the large-scale structure of the universe, all of it fits. The Big Bang is one of the most successful scientific frameworks we have. But, and this is the critical point, the Big Bang is not an answer to why there's something rather than nothing. It's a description of how the current universe evolved from a prior state. It tells you what happened after something was already happening. Push the model backward and you reach the Planck epoch, the first 10 to the minus 43 seconds of cosmic history, where both quantum mechanical effects and gravitational effects are so extreme that our current theories break down. General relativity produces singularities. Quantum field theory loses predictive power. The mathematics stops giving sensible answers. We do not have a theory of quantum gravity, a framework that successfully merges quantum mechanics and general relativity that can describe this regime. Proposals exist: string theory, loop quantum gravity, others. None of them are confirmed. None of them have given us a complete picture of the Planck epoch. Physics at present does not reach the beginning. It reaches very close to the beginning, and then the equations dissolve into infinities. The honest position is simple. We don't know what, if anything, came before, caused, or generated the initial conditions of the universe. Anyone who tells you physics has answered this is describing a hope, not a result. But quantum field theory does something interesting that's worth examining carefully. The quantum vacuum, the ground state of a quantum field, the lowest energy configuration, is not empty. It seethes. Virtual particle-antiparticle pairs constantly pop into existence, borrow energy from the uncertainty principle for tiny fractions of a second, and annihilate back. This isn't speculation. The physical effects of these vacuum fluctuations are measured. The Casimir effect, the tiny attractive force between two uncharged metal plates placed very close together, is caused by vacuum fluctuations being excluded from the space between the plates. The Lamb shift in hydrogen's spectral lines. The anomalous magnetic moment of the electron measured and predicted to 10 decimal places. Quantum vacuum fluctuations are as well confirmed as physics gets. Some cosmologists have suggested this is the answer. The universe arose from a quantum vacuum fluctuation, something from nothing. Lawrence Krauss wrote a book with that title, and the physics is genuinely interesting. In quantum cosmology, there are models in which a universe like ours can nucleate spontaneously from a prior quantum state, tunneling into existence the way a particle tunnels through a potential barrier. But here's the precise objection, and I think it deserves to be stated clearly. A quantum vacuum is not nothing. It is a quantum field with specific properties, obeying specific laws, existing within a mathematical framework that includes quantum mechanics, the uncertainty principle, the structure of space-time. When you say the universe arose from a quantum vacuum fluctuation, you still need to explain the quantum vacuum. You still need to explain the laws it obeys. You still need to explain why those laws, rather than other laws, or no laws at all. The quantum origin story is a real and interesting piece of physics. It is not an answer to the deepest question. It relocates the question by one step and leaves it just as open. Here's a more radical proposal. What if the laws of physics aren't imposed on reality from outside? What if the laws are reality? Max Tegmark, a physicist at MIT, has developed what he calls the mathematical universe hypothesis. The idea, every mathematically consistent structure exists, not as a description of something physical, as a physical reality in its own right. Our universe, with its specific particles and forces and constants, is one mathematical structure among an infinite collection of all possible consistent ones. You don't need to explain why our laws were chosen. Nothing was chosen. All mathematical structures exist, and we necessarily find ourselves in one that is complex enough to contain observers. This is either one of the most profound ideas in the history of physics or one of the most elegant evasions, depending on what you make of mathematical existence. Does a mathematical structure exist in the same sense that this table exists? Tegmark says yes, that the distinction between mathematical existence and physical existence is itself an artifact of our perspective, not a deep metaphysical truth. Most physicists are skeptical, but the hypothesis is precise, it makes predictions about the nature of physical law, and it forces you to ask a question you can't easily dismiss. What is the difference between a mathematical structure and a universe? If you can't answer that cleanly, the hypothesis is harder to dismiss than it looks. Now, there's an observation that doesn't answer the question, but reframes it in a useful way. Any universe in which someone is asking, why does the universe exist, must be a universe that permits the existence of beings capable of asking it. This sounds circular. It isn't. It's a constraint. A universe with no stable matter, or no chemistry capable of producing complex structures, or no time for evolution to operate, that universe, if it exists, produces no questioners. The question is never asked. We observe a universe compatible with observers not because it was designed for us, but because incompatible universes don't produce observers to do the observing. This is the anthropic principle. And while it doesn't explain why anything exists, it does explain something that looks like fine-tuning. The physical constants of our universe, the strength of gravity, the mass of the electron, the cosmological constant, appear to be set within narrow ranges compatible with complex chemistry and life. The anthropic observation is that if they weren't, we wouldn't be here to notice. In a multiverse with many regions of different constants, we necessarily find ourselves in a compatible region, not by design, by selection. This dissolves a layer of the mystery. It doesn't dissolve the core. You still need to explain why there's a multiverse, why there's a quantum field, why there's anything at all with the potential to produce regions. Let me tell you where the logic ends up, and I want to be precise about this because vagueness here is a form of dishonesty. Every proposed answer to why does the universe exist falls into one of three categories. The first, it appeals to a prior cause. The universe was caused by something, a quantum fluctuation, a prior universe, a god. But then that cause needs a cause, and the regress is infinite, which means you've deferred the question, not answered it. The second, it posits something that exists necessarily, that couldn't not exist, that exists by its own nature, that requires no external explanation. Mathematical structures in Tegmark's framework, God in certain theological arguments, the quantum vacuum in some physical arguments. But then you need to explain what necessary existence actually means. Is it coherent, or is it just a label for where we stopped asking? And you need to explain why this necessary thing has the specific properties it has, rather than different ones. The third, brute fact. The universe exists. There is no reason, it's just true. Some philosophers find this intellectually honest. Others find it unbearable. It's the option that says the deepest question has no answer. Not because we haven't found it yet, but structurally, fundamentally, because explanation itself has to stop somewhere, and it stops here. Physics, philosophy, and theology have been circling these three options for as long as serious thought has been applied to this question. None of them escape the circle. I don't think the circle can be escaped. I think the circle is the answer, or rather, the precise shape of the question. Now I want to add something personal, something from my own work. When I derived the relativistic wave equation for the electron in 1928, what became the Dirac equation, the mathematics did something I hadn't planned. It required the existence of a particle identical to the electron but with opposite charge, the positron, antimatter. The mathematics insisted on it before experiment confirmed it. And the implication was stark. Matter and antimatter should have been created in equal quantities at the Big Bang. Equal quantities of matter and antimatter annihilate completely. If the symmetry had been perfect, if the laws had been perfectly symmetric between matter and antimatter, the Big Bang would have produced equal amounts of both. They would have destroyed each other, and there would be nothing. No matter, no stars, no planets, no life, no question. The fact that you exist, that anything exists, means the symmetry was broken by a tiny amount. Roughly 1 extra particle of matter per billion matter-antimatter pairs. That excess survived. That's the universe. That's everything. Why was the symmetry broken? We have partial answers. CP violation, the breaking of a combined symmetry between charge and spatial reflection, occurs in certain particle decays and provides a mechanism for matter-antimatter asymmetry. But the known sources of CP violation in the Standard Model are not large enough to account for the observed matter excess. There must be additional physics we haven't found. The reason existence exists, the reason the symmetry broke in the right direction by the right amount, is one of the deepest open problems in physics. The universe exists because an imperfection occurred, and we don't know why. And now the final thought, the one I think earns the right to be said. You are a part of the something whose existence needs explaining. You are made of the matter that shouldn't, by the symmetric logic of the laws, be here. You are using a brain assembled from atoms forged in stars that formed from the matter that survived the annihilation that should have erased everything. You are inside the question. Every tool you have for thinking about it, logic, mathematics, intuition, language, is itself part of the something. You cannot step outside to examine the question from a neutral position. There is no neutral position. There is no outside. This is not an excuse to stop thinking. The thinking matters. The attempts to answer quantum cosmology, mathematical universe hypotheses, anthropic reasoning, the search for the physics of matter-antimatter asymmetry, these are real and important and worth every effort. But they operate within the something. They are the universe's attempts to explain itself. And whether a thing can fully explain itself, whether explanation of that kind is even possible, is a question that logic and mathematics have circled without resolution. The universe is not answering the question of its own existence. It is asking it, through you, through this, through every mind that has ever looked up and wondered why there's anything at all, rather than the silent, structureless, perhaps incoherent condition we call nothing. Whether that's the most profound thing imaginable, or the most absurd, or both at once, I find I cannot decide, and I've thought about it for a long time. That uncertainty, I think, is the most honest place the question leaves you.